Good day and welcome to One-on-One Maths Private Tutors. We continue with O-Level and IGCSE Mathematics for Cambridge and ZIMSEC on the topic of statistical diagrams. Let's look at scatter diagrams. A scatter diagram is used to find out whether there is a correlation or a relationship between two sets of data. The data is presented as pairs of values with an X and a Y coordinate, each of which is plotted as a coordinate point on a graph. Here are some examples of what a scatter diagram could look like. Strong positive correlation. Here, one quantity increases as the other increases. This is called a positive correlation. When the points are closely in line, the correlation is strong. Weak positive correlation. These points also display positive correlation. The points are more scattered, so the correlation is weak. Strong negative correlation. Here, one quantity decreases as the other increases. So as this quantity increases, this quantity decreases. This is called a negative correlation. Again, the points are closely in line, so the correlation is strong. So this is a strong negative correlation. Weak negative correlation. These points also display a negative correlation, but the points are more scattered, so the correlation is weak. No correlation. When the points are totally scattered and there is no clear pattern, there is no correlation between the two quantities. Line of best fit. If a scatter diagram shows correlation, you can draw a line of best fit on it. The line goes in the same general direction as the points and has approximately the same number of points on each side of the line. So this blue line is a line of best fit, same as this one. It's a line of best fit. That one is also a line of best fit, and this one is also a line of best fit. You cannot draw a line of best fit on a scatter diagram with no correlation. You can use a line of best fit to estimate a value when only one of the pair of quantities is known. An estimate should only be made if the given value is within the range of the data used in the scatter diagram. If it is outside the range, the estimate will be unreliable. So a line of best fit is an estimate. So we can use this blue line as a line of best fit there, or this line here as a line of best fit, or this line as a line of best fit. So it is drawn, just estimating, making sure that you have more or less the same number of values on one side as the other. Let's look at this question. The table shows the heights and weights of 12 people. Draw a scatter diagram to show this data. So our height is in this row, our weight is in this row. When we are given a table like that, the first set of data will be our X values, and the second set of data will be our Y values. And for our X values, we are ranging from 150 centimeters to 180 centimeters. So we go to our graph paper. Near the bottom, we start our X-axis. So we can start from 140, 150, 160, 170, 180. The X-axis is our height. We label it height in centimeters. Then we go to our Y-axis, which we can label as the weight in kgs. And looking at our range, we are starting from 56 as the minimum to 70 as the maximum. So we may start at 50, there, 60, 70, 80. So our scale is such that two squares are representing 1 unit. This is 50, that is 51. This is 52, 53, 54, 55, 56, 57, 58, 59, then 60 there. Also on our x-axis, two squares are representing 1 unit. If this is 140, this is 141, 142, 143, 144, 145, 146, 147, 148, 149, 150. So two squares are representing 1 unit. Now for the scale, 10 squares represent 2 centimeters. In this range, there are 5 units from 140 to 145. So we can say 2 centimeters is to 5 units. Is our scale for both the x and y axis. It is also important to make sure that the distance between 140 and 150 is the same as from 150 to 160 and 160 to 170 and 170 to 180. Students often make the mistake of having different scales between two corresponding points. So make sure on your x and on your y axis, if you choose a scale, it should be consistent. Now let's plot the points. For a height of 150 centimeters, the weight is 56 kgs. So 150 is here, 55, 56 is there. So this is the point, 150, 56. 152 corresponds to 62 kgs. 150, 151, 152 there corresponds to 62 kgs. 60, 61, 62. So the point is here. 152, 62. 155 is here. This is 155 centimeters is corresponding to 63 kgs. 63 kgs here. 60, 61, 62, 63 kgs is there. And 155 is there. Then we have 158, 55, 56, 57, 58. 158 is there. It's corresponding to 57. 55, 56, 57 there. So our point is here. 158, 57. Okay, our next point, 158 is here, corresponding to 64. 61, 2, 3, 4. 160 is there corresponding to 62. 60, 61, 62. So this is the point we are looking for. 160 on the x and 62 on the y. 163 is corresponding to 65. 65 is here. So the point we are looking for is this point here. 163, 65. Our next point is 165. 165 is here. And 66. 65 is here. 66 is there. So the point we are looking for is this point there. Next point is 170, 65. 170 is here. 65 is there. So this is the point we are looking for. Then we have 175, 70. 175 is here. 70 is there. So this is the point. The next point is 178, 66. 175, 176, 177, 178. 66 is here. So 178 is here. 66 is here. So this is the point we are looking for. Next point is 180, 67. 180 is here. 67 is there. So this is the point we are looking for. Next question is comment on the strength and type of correlation between these heights and weights. This is a weak positive correlation. Points are a bit scattered, but we can see a trend of increase, though it's not strong. So this is a weak positive correlation. Draw a line of best fit on your scatter diagram. This could be a line of best fit which shows the trend, and our line of best fit should be in the range we are given. So that is a good line of best fit. Nimau is 162 centimeters tall. Use your line of best fit to estimate his weight. So we go to 162 centimeters. So this is 162 centimeters. Take it up to the line, then take it horizontal to find the corresponding weight. So this is the value of the weight we are interested in, which is 63 kgs. So our answer for this is 63 kgs. So this is the answer to our question. Thank you.